Right now, your birthday is arriving late. Not by much, not enough to notice, but it's happening. Every second you spend near the ground, you are aging very slightly faster than someone floating far above you. Time itself is not one steady drumbeat for everyone. It bends, it stretches, it runs at different speeds, depending on where you stand and how fast you move. And the real answer to why is far stranger than anything you learned in school. You've heard the phrase before, time dilation. It sounds like jargon, so let's decode it immediately. Time dilation simply means this: time passes at different rates for different observers, not because clocks are broken, because time is not fixed, it's flexible. It bends around mass, and it slows down the faster you move. This isn't theory anymore. This is measured, tested, confirmed fact. It started with one man staring at a beam of light. Albert Einstein imagined chasing that beam at almost the speed of light. What would he see? The answer broke physics wide open. He realized speed doesn't just change your position, it changes your clock. The faster you move through space, the slower you move through time. Not as an illusion, as reality. Then he went further. Gravity, he said, isn't a force pulling you down. It's mass bending the fabric of space-time itself, and clocks near strong gravity tick slower than clocks far away. A person standing at sea level ages slightly slower than a person standing on a mountain. Earth's gravity is gently pulling on their time. Sound impossible? It's been tested. In 1971, physicists Joseph Haffel and Richard Kading did something almost comically simple. They put atomic clocks on airplanes and flew them around the world. Then they compared those clocks to identical ones that stayed on the ground. The flying clocks came back off, not broken, just slightly, measurably behind and ahead, exactly matching Einstein's predictions. Real clocks, real drift, real proof that time is not the same everywhere. You're relying on this fact right now, whether you know it or not. GPS satellites orbit roughly 20,000 kilometers above you, moving fast and sitting in weaker gravity. Both effects shift their clocks compared to yours on the ground. If engineers ignored the correction, GPS location errors would stack up by several kilometers every single day. Your phone's map would slowly drift into fiction. So every GPS satellite carries a built-in adjustment, quietly correcting for the fact that time up there simply isn't the same as time down here. Here's where it gets personal. In 2015, NASA sent astronaut Scott Kelly to the International Space Station for almost a year, while his identical twin brother Mark stayed on Earth. When Scott came home, researchers compared them in extraordinary detail. Because Scott had spent time moving fast in orbit, relativity predicts he aged a tiny amount less than his brother. Just a matter of milliseconds over the whole year, a fraction of a heartbeat, but real, measurable, confirmed. Two brothers, same birth, slightly different amounts of time lived just because one of them left the ground. Now stretch this further. Picture an astronaut orbiting close to a black hole where gravity is millions of times stronger than Earth's. Down there, time doesn't just slow slightly, it nearly stops compared to someone watching from a safe distance. 1 hour near that black hole could equal years back home. Come back and everyone you knew has aged without you. Your friends are old. Your world has moved on. You haven't aged a day. Isn't that the strangest kind of time travel? Not backward, not forward, just slower, one uninvited step out of sync with everyone else. So why does any of this matter to you standing on solid ground, reading this in an ordinary moment? because it means the version of now you're living in isn't universal. It's local. It's yours. Somewhere above you, astronauts are living a version of this exact moment, measured in slightly different units. Somewhere near a black hole, time is nearly frozen. Somewhere in deep space, a spacecraft's onboard clock has quietly drifted from Earth's. There is no single master clock ticking for the whole universe. There's only your clock and everyone else's clock, each one shaped by how fast they're moving and how strongly gravity is holding them. You are not just living through time. You are shaping it just by existing where you exist, moving how you move. So the next time you look up at the sky, remember this. Somewhere up there, a satellite's clock is out of sync with yours. An astronaut is aging a fraction slower than everyone they left behind. And you, standing right here, are the version of now for absolutely no one but yourself. Your birthday really is arriving late. It just depends on where you're standing when it finally gets there.